All right, here is for the few students who miss the old-fashioned lecture style. Here we go. Chapter 7 is called Alkynes. For something to be an alkyne, it needs to have a carbon with a triple bond to carbon. There are two major types of alkyne. There are terminal and internal. Terminal means there's an H on one end because it's the end of the chain. Terminal, end of the chain. And some number of carbons before. Internal, there's a C on each side at least. Okay? Which of the two types of alkynes has a pKa that we're supposed to know? Please don't give me a pKa for an internal alkyne. There's no H attached to an sp carbon. It's not an alkyne H. So pKa 25, that's not new. All that's new is internal alkynes don't have that H, but we knew that before. Okay? pKa equal, if you had to give me a pKa, you should be able to do it for the next one, but don't give me 25. All the other carbons are sp3. They're called alkane carbons. What's the pKa? 50. So example, this H here, right? Any of the H's on an sp3 carbon are 50. Naming, nomenclature. In green, 1, 2, 3, 4, 5, 6. I don't think nomenclature is going to take a lot of time. What's the only new thing in that name that you didn't use before? The Y, exactly. And the Y means what? Alkyne, which is what kind of bonding between two carbons? 3 bonds, 1 sigma and 2 pi's, right? Now the other one, where should you start, left or right? Remember, alkyne needs to be on the lowest possible number. You should start on the left, because that way it ends up on starting on 3. So this one, give me its full name. 2-methyl. 3. 7 carbons. Heptyne. Okay. Hep3-ine. Or both names can be redone. Oh, no, I messed up. Hex. I mean, is this really new either? Is that new? No. Same story here. 2-methyl Hep3-ine. I'm going to do a third name for each one, based on a new thing that you don't know yet. This molecule is called, well, you should be able to give me the name we've been doing so far. 2-carbon alkyne, it's terminal, right? You could argue it's di-terminal because it's terminal on each end, but let's not get picky. It's terminal. But 2 carbons, what's your prefix? Yeah, it's ethyne. That's very British pronunciation, by the way. I like it. Here's the name you got to get used to. Has anybody heard of acetylene? Who uses acetylene a lot? Other than some synthetic organic chemists. There's other people, another trade that uses a ton of acetylene. They buy it in cylinders under pressure. They mix it with oxygen. And they light it on fire, and it burns incredibly hot. Who's doing this? The name of their job starts with a W. A welder. Nice job. A welder. My son-in-law is a professional welder who trains other welders, so welding's in the family. But I was teaching about welding before he was even in the family because of this. Why would acetylene burn incredibly hotter than, say, ethane, which has the same number of carbons? Stronger bonds in ethane. What? Whoa, you thought the opposite, right? No. How many bonds are in acetylene? Total bonds. Just count the sticks you see there. 5. What percentage of those bonds are the less stable pi? 40. 2 bonds out of 5 are pi. Do you agree? Guys, less stable. Talk to me about potential energy. We're gonna go stop share. Combustion. You're burning stuff, right? Does it give off heat or require heat? Go to your campfire. You're not putting your hands there to get them cold because the reaction's giving off heat. It's exothermic, right? So which reaction gives off more heat? We got reactants are fuel, products are CO2 and water. Exothermic means reactants are less stable and products are more stable, right? And we're releasing heat. So if your reactants all of a sudden now have pi bonds, they go up here. CO2 and water are still here. They're the same molecules they were before. What happened to your delta H? Here compared to here. Yeah, there's a bigger difference between those two. That's a higher delta H than when you started with the more stable alkane. Ethane gave that much heat. That difference there. Ethyne here. Because there's a higher percentage of unstable pi bonds, you get more heat. Got it? So that's why it works for welding. Back to sharing. Wasn't double clicking fast enough. Tell me if I lose anybody with this third name here in, I keep losing my pen. Where did I put it this time? Ooh, did they go to the ground? It's a sign. It's a sign that we should be finishing soon. That's really bothering me now. Pause. We had nothing going on and I was talking. Some can argue that happens a lot more than I think it does, but let's not go there. Starboard. Here we go. Does this name surprise you? Butyl acetylene. Where's the acetylene? Should I recolor it? There's acetylene. What's that group to the left? Butyl. So this is not UPAC. This is a common name. Common. The 2 previous names are UPAC, International Union of Pure and Applied Chemists. UPAC. What would you call the next one? What are the 2 groups attached to acetylene this time? Well, the first time there wasn't 2 groups, sorry. There was only 1, so I listed it. But now there's 2 groups attached to acetylene. I want them listed alphabetically. And iso should go 1, 2, 3. Yes, isopropyl goes first. Isopropyl, and then what's that group on the right? Yes, sir. And is anybody thinking, well, don't you have to tell me where the groups are? No, you don't have to. You can't have both groups on one side. That's an octet violation. They have to be one on one side and the other on the other, right? So that's the common naming system. I mean, it's equally adequate. On my nomenclature sections, I never tell you which system you have to use, do I? It doesn't say use the UPAC name. OWL can drive you nuts doing that because you named it perfectly, but you didn't use the UPAC system, and the OWL just tells you you're wrong. I don't do that to you. Okay, so nomenclature, what else can we get into? pKa. Let's just make this mostly review. Give 4 bases that give a high yield in this reaction. Now, I have a very liberal definition of high yield, just greater than 50%. Greater than 50% yield. And I'm going to tell you why your favorite base is not an adequate answer. What's your favorite base? We talked about earlier. Somebody just mentioned it. OH minus. You think, well, it's got to be a good base, right? It is not a good answer. Here's the reason why. OH minus, I'm just telling you, you're getting nothing for. It goes to OH with an H, hypothetically, and C minus. What's the pKa of water, which is right here? What's the pKa of a terminal alkyne? What's the pKeq for the reaction? I'm going fast because I need this to go fast every time you see it. Yeah, you're not getting any tests off of this, ever. Well, test 1. You got test 1 off, and no more. Every test, there's pKeq questions. This course and the next course. So, you take the left acid, which was the 25, minus the right acid. This is bad news. That's why you have the wrong answer. KEQ, there's almost nothing on the right side. It's 10 to the negative 9. That's a huge sad face. I need KEQ to at least equal 1. 1, because that would be 50% products divided by reactants, right? 50-50, that's what K is. Concentration of products divided by concentration of reactants is K. You need more products than reactants in this question because the teacher said I need a more than 50% yield. I hope that's clear. Think about those words. Pause the video, think about the words, come back, okay? So you need stronger bases is what I'm trying to say. You've got a lot more on the table above water. Remember, if the acid's getting weaker, what's happening to the base strength on that table? Stronger, because pKa and pKb add to 14. If one of them's going up, the other's going down. We need it to go down, pKb. So why don't you just give me the strongest base you can think of? Answers. You're having trouble? The answers will be here. They go to HA, okay? The base is in the box going to its conjugate acid. How about H bonded to CH3? What's the pKa? 50. That is certainly going to be an adequate base that goes there. Give me the conjugate base of HCH3 in this green box. CH3, you're going to half credit with a minus. There you go. Same story. What's your next strongest acid over here? pKa table. Double bond. 45. Therefore, in the box, conjugate base. Oh, black. Oh, I guess I took it off the right side. Sorry about that. That's PKB negative 31. Two more. Amine. So don't give me the amine as your answer, right? That's the conjugate acid. Want to stick with methyl as much as we can? Keep it simple. That means in the box, you had N minus, and that was a 40, right? And wasn't there a 35? Which acid has a pKa of 35? Hydrogen. Now, guys, be careful. Give me the conjugate base of hydrogen. Do not put H plus in that box. H minus. I didn't put lone pairs on the other one, so you don't need the lone. Oh, I remember I had my big eraser out earlier. There's your 4 answers, and that's a nice finish. Wednesday, we talk about those bases being really important for using acetylene in synthesis. Read ahead. Try to finish chapter 7 reading before Wednesday. Okay? And that will do us for today. And I'll come and get those activities